So this next section we're going to be looking at is nitrogen. And this is the update that a lot of people have been asking me the most as far as, and this is rates. We do have some other work on timing of application, single and split applications. I don't have that today, but we do have that I'm working on, kind of finalizing some of the information there this winter. So this is our nitrogen in corn. Just kind of some interesting people like to ask, what are we normally seeing? So here we're looking at our economic optimal nitrogen rate. These are the different research sites. We have about 45 in the database right now. Hopefully some more coming this winter with some other researchers. You can see we have ranges anywhere from, we took 0 nitrogen, so no response, from 11 up to 200 pounds of N per acre before we optimize. And that mean is around 96 pounds of nitrogen across all of these sites. And these zeros are not just because we had droughts. About 2 of these 7 sites were because of drought, and the other ones were practices that the farmers used were just good soil health and they had good yields for them. But it's just a kind of interesting thing here. So we look at this right here, this graph shows us yield versus that optimal nitrogen rate. So you can see that the yield didn't necessarily, just because we required a lower amount of N, didn't necessarily mean we had a lower amount of fertilizer. So this Field and Garrettson right here had required about 50 pounds of N, but still yielded 235 bushels. And the field over here that required 200 pounds of N yielded 215 bushels. So it wasn't necessarily just because we have a higher yield, it required more nitrogen fertilizer. But this is just kind of an interesting, people like to look at this number, kind of show you there. We have a range of what is optimal for our nitrogen fertilizer rate. But so there's a couple different systems for nitrogen recommendations. There's what people call it the traditional yield goal system, which we base our nitrogen fertilizer rate on our yield goal and our soil test and legume credits and a multiplier for pounds of N per bushel of corn. And there's also kind of that in conjunction with a maximum return to nitrogen. Depending on how much time we have today, we will hit on the maximum return to nitrogen, how it looks like in South Dakota. If we don't have enough time, you can go to that YouTube page, and there's a few videos on what those numbers are in South Dakota and how accurate it is compared to the yield goal system. But we'll hit on the yield goal system and its accuracy first today, so this one. So just a quick reminder of what this system is and what it looks like. We're looking at that our yield goal, we're going to just say 144 bushels per acre in this example. We're going to multiply it by that coefficient of that 1.2, which is pounds of N per bushel of corn. We're going to subtract our soil test N. We grew up after soybean here, the legume credit is 40. After alfalfa, it's different. If we're new no-till within about 5 or 6 years, we'd say likely you need to add about 30 more pounds of N, just because the microbes haven't gotten used to that no-till system and got caught up. It takes a few years to get that. And if you do all this, this recommendation, say 105 pounds of N, you're using urea, so 46% N, 228 pounds of urea per acre. So with that, the question is, that's our equation. That's the system that we use. You can also use manure credits in there, but we're not going over that today. So, but how accurate is this system? So from 2018 to 2022, you can see the map here. These are the counties where we've had different research locations. These are the ones that are currently in the database. We do have about 7 more that are from the central region. I just haven't gotten the researcher to give me the data yet to make sure they get in there. But there are some other sites that will go in this database from the central part of the state. So about 32 sites of those are conventional, 13 are no-till. If you're interested, we're doing more sites this year and we're looking for farmers and cooperators. So we can definitely help get your farm on the map and get you some data as well for either conventional or no-till. Previous crop is soybean most of the time, wheat, corn, and some other one, and about in 10 sites, but most of the time we're following soybean. We have some sites that are following corn as well. So this one we're going to start off by just looking at what was the SDSU recommendation and versus what we actually needed and how accurate that is. So here on our y-axis, we have our pounds of nitrogen per acre. So this is how much was required. Down here, we have, these are the sites in the central South Dakota, and these are sites in eastern South Dakota. So we do have more in the eastern sites, just where I've had farmers let me use their fields more often, but we are looking to hopefully get more in the central. If you're interested, let me know. So this red line is, again, the SDSU recommendation. So what we want to see is this red line versus this blue line you're going to see in a minute. You want them as close as possible because that means that we're accurate. So we look at the blue line, you can see for the most part, we're not too far off. We do have some sites where we need a little bit more and have some sites where we over-recommended fertilizer by quite a bit. We have some sites like over here where we're perfectly accurate versus the recommendation. But to make this kind of a little bit easier, what we're going to do is this next graph, we're going to take this red line, and subtract the blue line. So we're just going to look at the difference between these red and blue lines. So that's what this graph is here. So that means if we are at 0, that means the SDSU recommendation minus the actual required N was 0. That means it was right on. So we want to be close to that 0 line. If we are under that 0 line down here, that means we underestimated nitrogen requirement. If we're above it, that means we overestimated nitrogen requirement. So we just look at that 1.2, what we've been using for several years. We can see that generally we are on the upside here and we are overestimating, anywhere from 90 to 180 pounds per acre. We do have some sites where we're underestimating them. A couple of them are like this WPU. This was a drought site. This was a drought site. This one had some drought issues. This one over here was drought. So we tend to underestimate when we have drought issues because our yield is a little bit different than what we thought. So that's what this one is. And so we're accurate by plus or minus 67. So we're, an average of 67 pounds of N per acre from 0 in this. And the reason why a lot of this, we can obviously see we have a good amount of room to improve here. And just to briefly kind of show us and talk about a little bit of why some of this might be happening. So we look at just the changes in ag in South Dakota. You can see, we've been increasing corn yields over the last 10 or 15 years. Fertilizer rates has increased, use has increased, our climate is changing, we're getting a little bit warmer, rainfall is a little bit more sporadic. We've had a lot more increases in soil health measurements that we're using to make decisions. And a lot of farmers over the last 20 years have done a lot of changes in management practices. And a lot of those have to do with what we've talked about as different soil health principles. We're leaving, we're arming that soil, we're leaving residue on the soil to help keep the soil there, help keep the nutrients there. We're minimizing disturbance. We're tilling a lot less than we were 20 years ago. Some of us, a lot of people have been working on diversifying their rotation, getting more crops in there, trying to do as much as they can with getting roots in there, either incorporating perennials, doing cover crops, things like that. Some of those who have livestock or neighbors with livestock, they can integrate that. And so all these things have really, what they do is they alter that nutrient cycle. They alter the amount of nitrogen cycling in there and keeping its availability there. So a lot of this is we've had a lot of changes. So how can we improve? So if we look at this recommendation and these different parts, the one that we've seen change the most through time is this one right here, this coefficient or this multiplier of 1.2. And as a reminder, we've talked about this in previous times, but just where this comes from, so we take our soil test nitrogen level from 0 to 24 inches. We add that to our fertilizer rate required to optimize yield, say 240 pounds of N per acre, add those two together, a 200 bushel per acre yield. We do the math there that shows we needed 1.2 pounds of N for every 1 bushel of corn. So now the question is, how accurate is that? And is it still changing? So if we look at these sites right here, again, we can see that nitrogen coefficient right here. If we are, so this right here is that 1.2 mark, where we have been traditionally in the past. And what we see, if we look at these sites right here, we're actually a little bit lower. We're closer to that 0.9 or 1 mark. So we're actually getting more efficient, which is a good thing. We're improving, we're lessening the amount of nitrogen that we need per bushel of corn, which is what we want to do. We want to become more efficient. So here, if we go back to this graph where we're looking at our nitrogen recommendation subtracted from that nitrogen needed, and we look at this is what we saw before. This is that 1.2 difference. Now, if we look at this blue bar next, we're going to look at a 1.0 different. We're going to look at the difference using a coefficient of 1.0. And what we want to see is, do we tend to get closer to 0 with this blue bar? So we can see when we're above here, when we're overestimating, that red to blue always is getting close to 0 for the most part. We have some where it kind of starts to go to the other side that we're pretty accurate in the first place. And these ones down here where we're underestimating before, we're underestimating more, which makes sense because you're decreasing the amount that you're applying there. But some of these are the drought sites. So that's to consider. And now if we go to this yellow line, the 0.8, using that as a multiplier coefficient, we see that those ones that are higher tend to get closer to zero still. However, a lot of times we're moving from being overestimating to now underestimating. So we're going to do next, we're going to take these sites and kind of group them into categories. We're going to do those ones that tend to really overestimate, the ones that are really high in underestimating, and then the ones in the middle. So again, this is similar. This is that zero line. We want things as close to zero as we can. So underestimating these sites right here, if we go from the blue to the red to the blue to the yellow in that 1.2, 1.0, 0.8, we see that we tend to be moving farther away from zero, which isn't what we want, but these also are the sites that tend to be drought stressed. So they're not, the thing we want to consider the most. The next thing we want to do is these sites over here, we tend to overestimate nitrogen. So as we are decreasing that coefficient from 1.2 to 1 to 0.8, we see we're getting closer to that line, which is what we want. And then if we look at that middle 50% of the data, which is, probably the most normal typical years that we have in South Dakota as far as that frequency around normal, we see as we go from 1.2 to 1 to 0.8, we're getting closer to that zero line. And we're staying more around it. Actually, if we go to 0.8, we tend to be actually going more below that line, which may not be what we want. We want to kind of be evenly spaced on both sides of there. So if we take this data and just look at it all together, which is what we'll do on this next figure, we want to be around zero. So we look at that 1.2 to 1 to 0.8, we see that on average, this line right here is the mean, the X is the median. We get closer and more around that zero line. And if we look at just, if we look at the average, we're plus 48 pounds of N per acre, plus 13, and then we switch here to go negative 22. So we can see that as we go below 1 to 0.8, we tend to be underestimating more. Where this one, if we see this box right here, which is 50% of the data, that center 50%, we see that we're pretty straddling that box around zero, which is kind of the best that we can really do. So that kind of shows us that 1.0 is going to be more accurate. The red 1.2 tends to overestimate, 0.8 tends to underestimate, and 1 is kind of straddling that line there. And this changing in 1.2 isn't normal, isn't new. If we look at this equation right here, this 1.2 has actually changed throughout time. 1975, we were 1.45, 82 changed to 1.3, 91, we changed to 1.2. And if we look at 2022, the best numbers are that 0.9 to 1. And if we're a little conservative, that 1 gives us that best around zero, kind of getting that accuracy the most we can right around there. So that's kind of showing us there as well, that we can be really accurate when we're right around there. So another thing, so we're seeing if we go from 1.2 to 1, we're improving it and we're being more accurate and we're saving some money on fertilizer. The other thing is, if we look at these different factors that we have in this test, how important are they? And this is just kind of something considered when we look at each of these. Is it the coefficient, the soil test N, the legume credit, no-till debit? Which of those do we make sure we're using when we're in this equation? So this is just the amount of times if we use these different factors, how much they're improving our nitrogen recommendation. So here, and this is a percentage of times. If we use that 1.2 to 1, instead of using 1.2, we'll use 1. Now we're looking central part of the state doesn't improve as much, but we're looking 70 to 80% of the time, we're improving our nitrogen recommendation. If we use soil test N, it's pretty high, 60 to 80% of the time, we're improving our recommendation. Using that legume credit, again, 70 to 76% of the time, we're improving our recommendation. The no-till, again, we're most of the time, we're improving the recommendation by using it. So they're all really important. We're going to look at some numeric numbers of the amount that they improve it in this next graph. So here, this is instead of percentage of time, we're looking at pounds of nitrogen per acre improvement. So how much by using these do we get closer to zero, getting closer to that actual recommendation. So if we move from 1.2 to 1, we improve our accuracy across the whole state by 19. Central part of the state, not as much. They tend to need a little bit more nitrogen, but it is still improvement. Eastern region, around 23 pounds of N, you're getting closer. So you're saving 23 pounds of N by using that 1.0 instead of 1.2 on average. Soil test N is even better, shows how important taking that 0 to 24 inch sample is you can save, become more accurate by 25 to 29 pounds of N. And if we're thinking, nitrogen per pound of N is $1.03, that's $25, $30 an acre that you're saving. So it's very well worth a $5 or $6 nitrogen test, whatever they're at right now. That legume credit, to use it properly, we're improving by 13 to 17. The no-till is this is interesting because it's negative, but it's negative kind of in a good way. We're seeing a lot of the sites we have in the database are longer term no-tills, so longer than 5 years. So I just included them in this data set to look at. If it's no-till, we added the 30 pounds. This shows us that on average in these longer term sites, we don't need this 30 pounds of N. So that's likely going to have some more stipulations on it, because once we hit that 5-6 year mark, we see that you don't need that plus 30, and that's why this is negative. We're seeing that those sites don't actually necessarily need that all the time. So that's kind of our system that we've been using and how accurate it is. The next thing we'll look at is this maximum return to nitrogen approach and its recommendations. So, we see this is the yield goal approach. We changed that coefficient to 1.2. So now what about economics? So if we look at economics really quickly here, this is a field in Salem, South Dakota. We did a couple years ago. We have corn yield here, nitrogen fertilizer right here. We can see a response curve here. We can see the points, and we draw a line through there. We can see that we increased in yield until about right here, 120 pounds of N, we had 225 bushels of corn. So at 0 pounds of N, when we didn't add anything, we're about 120 bushels of N. If we add 40 more pounds of N, we increase by 54 bushels per acre from 0 pounds of N to here. So we go from 120 to about 175. Now, if we add 40 more pounds of N, we increase by 34. If we add another 40 pounds of N, we increase by 14. So here you can see that it's not necessarily a linear relationship. We're not seeing an increase of 54 each time we put 40 pounds of N. You're seeing as you increase in N, the return you're getting back is less and less. So that's why we need to consider economics, because this last 40 pounds only got us 14 bushels, where the first 40 gave us 54. So that's an important thing to understand, is that these last bushels, we put the same amount of N, we're not getting as much back. So what maximum return to nitrogen does, it doesn't just look at nitrogen rate and yield, it looks at the profit from yield versus the cost of nitrogen. So we've looked at these ratios before. Last time we looked at pounds of N per bushel of corn. Now we're going to look at price of N per profit of corn bushels. So traditionally, we're looking at 40-cent N, $4 corn. Some of you might wish this was closer now, but we'd say, 0.1 ratio. You'd see this in Iowa and Minnesota and North Dakota a lot. They use 0.1. That's the long-term traditional. What that means is it takes 0.1 bushels of corn to pay for 1 pound of N. But for today's prices, we're looking at $1.03 N, $6.95 corn price. So we're actually looking at, we need to be able to produce for every pound of N, we need to increase in 0.15 bushels of corn. So to kind of look at that as a more bigger numbers, excuse me, you need to have, for every 40 pounds of N you apply, you need an increase of 6 bushels per acre, if we're to kind of upscale those values right there. So just to kind of really quickly talk about agronomic versus economic, so we're going to have the same terminology here. Agronomic optimum N rate is the N rate at maximum yield. Economic is the point where my increase in yield pays for that additional N. And we'll look at an example here in just a second. So this is a site in Brookings, South Dakota, on a farmer's field about 10-15 minutes from campus. We look at the response curve here. It goes what we typically see. If we look at agronomic, where N equals 85, yield equals 224. If we incorporate economics into it, that nitrogen fertilizer rate falls from 85 down to 76. We only lose a bushel, but we also decrease the amount of N by about 9 pounds of N per acre, which this isn't always the same in every field. This is one field. If we look at another field, about 10 miles away from that field, same year, we have a response curve that looks a little bit like this. So a little bit, slower increase in yield. So the optimal N rate technically was around 206, but if we incorporate economics, as we see how slowly this increases in yield, we only would need around 148, and the difference in yield is about 5 bushels. So this last 60 pounds of N did not pay for itself. So the economic was only around 150. But that doesn't happen in every site. That's kind of two different extremes. But if we look at this site in Brookings, we're going to now, instead of looking at yield versus nitrogen rate, we're going to look at nitrogen rate on the x-axis. We're going to switch this over to dollars per acre. So we're going to look here at the nitrogen costs, and it's linear. You imagine, put another pound of N, it increases cost the same amount. Now we're looking at the green line will be yield return to N. So that's going to be our profit from the corn yield, and it goes up. And at some point it's going to plateau because we're no longer increasing in yield from adding more nitrogen fertilizer. So this next line is then doing economics. We're taking the profit in the green line and subtracting it from the cost in the blue line, and then we get a response that looks like this. And that maximum point right here is 75 pounds of N per acre. That's the best economic value. And then if we go plus or minus $1 from there per acre, gives us a range about 70 to 80 pounds of N per acre would be your economic best rates. So that's what that maximum return to nitrogen focus does, is that it takes, instead of doing yield per pound of N, it's taking dollars per acre per pound of N that you're doing on there and getting these. And what it does is it fits a lot of these, as many sites as you can, puts them in a database, puts them together and graphs them like this to show us the difference that we're going to see there. And I do have an Excel sheet that kind of shows some of this stuff, but we don't have a lot of time to do it today. I'll just show you the accuracy. But if you're interested, you can send me an email and I can walk through the Excel sheet that shows the South Dakota data. So if we're to do this for MRTN for South Dakota from 2018 to 2021, the South Dakota recommendation would be 103 pounds of N per acre. If we divided it by central and eastern South Dakota, it would be 105 for east, central would be 81. So if we look at accuracy of that, if we use just the MRTN for that one, we can see we're about, about 40, 50 pounds above, accurate. If we use east and central, we can see central gets better. We normally get closer to that line that we'd want to see. So it's important that central versus eastern is definitely different. Eastern doesn't change much because the recommendation doesn't change much if we take out central and just look at east versus central. We can see how if we use MRTN approach, definitely in central part of the state, we need a different recommendation than east. So if we're to look at accuracy of this, we're about plus or minus 40, plus or minus 37 in the east, central plus or minus 50. This is predicting 2022's data. If we're to put 2022 into that database and then look at all of our sites 2018 to 2022, we can kind of look at that here. This just shows us, if we're to use that 80 pounds, 3 of the 5 sites were within 30 pounds of N per acre. We over fertilized 2. Here we have one that we under fertilized 1 and over fertilized 4 sites. So it's some things to think about. Now, if we add in 2022, we go from 103 to 97 for whole of South Dakota, 81 to 60. Here, so this is the accuracy. Again, this is all of South Dakota. MRTN approach is red, blue is east and central. So you can see again, blue gets closer to 0 for the most part when we have it there. Doesn't change as much here. Our accuracy does improve. So it went plus or minus 50 to plus or minus 42, and these numbers improve. That just shows you this approach really it's a data heavy approach. So we only have 45 site years. If you look at a state like Minnesota or Illinois has like 700 sites in their database. They have a lot bigger state, and they've been doing this for many years. Minnesota has, several hundred. So this is an approach that over time becomes more accurate. And so we started the database. We have 45 site years in there. 45 locations. We'll continue to look at it and see how that accuracy changes as we increase the number of locations we have in the database. And this just shows us the accuracy of those. If we use that rate, 14 and 45 within 20 pounds, we're under fertilizing 10 sites, we're over fertilizing 21 sites. So we can still definitely improve in the MRTN fashion, but it's getting better as we put more data inside of it. So these are just those, and the biggest comparison we'll look at here. So again, if we use that 1.0 coefficient, we're 13 on average over plus or minus 45. We are seeing some pretty similar values using MRTN, but we tend to be over fertilizing a little more than what I like to see. But I'm hoping that over time this can improve, and if it is, we might move to some different systems and incorporating some other soil test levels is what we're looking at as well. Let's see. That's what we're looking at. So South Dakota, kind of a summary, is looking at the yield goal approach. We're definitely going to be moving from 1.2 to 1, and that's more accurate for what we're seeing. Those official recommendations will come out this spring. We're just kind of reviewing them with as many people as we can this winter, and they'll be official out, and there'll also be a workbook, an Excel workbook that has all the information and all the equations in there to help people with understanding the SDSU recommendations as well. And that'll be hopefully on a website around the middle of March. We're still working on a few different things there. But so I guess I can take any questions or things like that.